What's up? What's up? What's up? It's your boy, the network. And today's topic is starvation, which is section 1.58 alpha of the CCNP route exam code 300-101 version 2.0. This is a subsection of section 1.5, describe UDP operations. And let's go ahead and look at the exam blueprint to see where we came from and where we're going. It's the blueprint, again, 300-101. We are currently we started in 1.5, describe UDP operations. We just wrapped up explaining TCP operations, global synchronization. We're doing starvation right now, and after that, we're going to do UDP latency. Notice how there's a latency in TCP traffic and also latency with UDP traffic. For now, we're doing starvation. Starvation is a phenomenon that occurs when you have TCP traffic and UDP traffic at the same time going on at your computer, right? But you have more traffic that's delegated to your UDP traffic as opposed to your TCP traffic. And this happens. Now, this is the tricky thing about what they did with the blueprint here. As you can see, it says here to describe UDP operation, right? Starvation is not a UDP operation. Starvation is something that occurs with TCP traffic. Now, UDP dominance is what happens when there's too much traffic that's delegated to UDP traffic, which causes TCP starvation. Now, when I think about this topic, I think about the movie Twins. Now, I don't know if y'all remember this movie. It's an old movie with Arnold Schwarzenegger and Danny DeVito, right? So basically, it was a movie about twins that were separated at birth, right? But before they was born, like when they was in the womb, apparently, with the embryo, when they was in the womb, right? One of the twins was getting all the nutrients and all the resources, most of it. And when they was born, one of them was, he was larger, he was stronger, he was smarter. He was basically the better human than the other one, which was Danny DeVito. He ended up being this sort of not very bright guy, and that's what kind of reminds me of UDP dominance versus TCP starvation. So think of Arnold Schwarzenegger as the UDP traffic. Now, Danny DeVito, he would represent the TCP traffic, right? Because UDP traffic, now if you remember the difference between the two, TCP usually has this three-way handshake that we've talked about multiple times that happens before it communicates, right? It does that, and then it also has these mechanisms when it realizes there's going to be some congestion. It does slow start. It starts throttling its speed. It starts speeding it up. It starts slowing it down, and it starts speeding it up. It starts slowing it down to kind of control the traffic. UDP don't have these mechanisms in place. It just keeps sending traffic. It keeps sending traffic. It don't care what kind of, what's going on with the network. It just keeps sending traffic. This phenomenon, like I said, causes UDP dominance. And when there's UDP dominance, you have TCP starvation. It's like, hey man, what's going on here? You taking up all the traffic. It starves the TCP traffic. That's why it's called TCP starvation. Now, the official definition from Cisco. I told y'all I'm going to try to do my best to keep these definitions from Cisco. Starvation, when TCP flows are combined with UDP flows and within a single service provider class, and the class experiences congestion. TCP flows continually lower their transmission rates. Like I said, it slows it down, slow start, whatever, potentially giving up their bandwidth to UDP flows. That's Arnold Schwarzenegger and the UDP traffic that are oblivious to drops. It don't care what's going on with the TCP traffic. This effect is called TCP starvation / UDP dominance. That's why I said that this is a misnomer, because it says to describe UDP operations, starvation. Starvation is not a UDP operation. Starvation is an effect that occurs with UDP dominance. So this is TCP starvation that's caused by the UDP dominance. Don't get tripped up with that. Now, why is it bad, you may ask? Well, increased latency. When you have too much UDP traffic and then your TCP traffic slowing down, then there's some traffic that was supposed to go from the TCP that's not going through because of the UDP dominance. That causes latency. So you're going to have increased latency. We talked about what latency is, right? Slowness in your network. You're going to have more congestion. UDP keeps dominating. You're going to have some starvation from the TCP traffic. You were supposed to get some TCP traffic, but it's being starved. So you're going to get some congestion because of the slowed down TCP traffic. It also lowers your bandwidth. Again, that's like bottlenecking and congestion. It lowers your bandwidth, so you ain't going to be able to maximize your network speed, right? I'm trying to keep it low because I got family sleeping and stuff. So that's why TCP starvation is bad. We don't want that. We're not going to do any hands-on today. We're going to keep it short and simple. That's basically what TCP starvation is. It's caused by the UDP dominance. Now, the solution to that is separating your traffic. Now, to get into all of that, this is kind of beyond the scope of the exam, but that is one of the things you can do to kind of remedy the effects of UDP dominance and TCP starvation. You separate your traffic. It's not always easy to do because some applications require both UDP and TCP traffic, so you got to kind of separate that to mitigate this problem. And there's also marking. That's kind of beyond the scope of this exam too. That's like quality of service, where you market some of your traffic. That when you market, that's separating your traffic. You're saying, okay, keep some of the UDP traffic here, the TCP traffic here. When you do that, that kind of helps, with the TCP and UDP dominance effect. Again, we're gonna keep this short and simple. If you like this video, go ahead, comment, like, subscribe. If you feel like you can give some more input to this, go ahead and put some comments below. Please subscribe to the network.